but maybe it's not up until Sue presses it.
Oh yeah, she has to hit live.
Gotcha.
I just went live, everybody. Thank you, Amy. I see we have some people joining us. Hi, everyone. Hi, everyone.
Hello.
Hi. We're streaming live from the Wagner Free Institute of Science. Welcome. I think we've got our full staff here today, both on site and all over the city at rivers and streams, at Tinicum, at Cobbs Creek. And we're really excited to be part of the Delaware River Festival this year on a really beautiful day. I'm live streaming from the Wagner in our historic lecture hall. And I'm just going to do a quick intro, and we'll tell you a little bit about the Wagner before we join our staff all over. If people have questions, you can do it through chat, but we'll also be answering questions throughout the program. And also at the end, we've got a Q&A with some time allotted. And you can also join us by zooming in and out today, or hang with us for the whole 2 hours and learn more about the Wagner, about our programs, and of course, a lot about the Delaware River and our rivers and streams and how important they are to our health. Real quick, what is the Wagner? We are a 19th century natural history museum and educational institution. We've been around since 1855, and our mission is free public education and science. We've been doing it since the day we opened, and we still offer a wide array of free educational programs in the evening and during the day for adults and children. We'll be starting a lot of our formal programs this coming week. We have partnerships with local schools, a program called GeoKids, where we go in and teach kids about science, and lots of things that anyone can join us for. We do free public adult education programs, but we also have this amazing historic site where I'm talking to you from. It was built in 1865. We've been operating out of it since that date. And we're right near Temple University in North Philadelphia. You can see, I hope, on the screen a picture of our exhibit hall that was set up in the 1890s and hasn't changed. We also have a historic library and archives where you can deep dive into our history and the history of science. And our librarian a little bit later will be sharing some items from those collections. We have our museum educator, Erin Lawson, here with us today. And we're going to be switching over to our museum, and Aaron will be sharing some of the work that he does, educating people from our astonishing 100,000 plus natural history collection. So I'm going to turn over to Aaron up in the museum in a few seconds. And we're still admitting people. I know people are joining us. I hope you all can hear. This is our first live stream for a big program like this from the museum, and we're really grateful to the River Festival for asking us to join them this year for this pilot virtual program of the River Festival. Aaron, are you there?
I'm Sue. Can you hear me?
Yep, I can.
Awesome. So thank you for that introduction, Sue. Again, my name is Aaron Lawson. I'm the museum educator here at the Wagner. And right behind me, as you can see, this is our historic museum gallery with, like Sue said, about 100,000 specimens, including rocks, fossils, taxidermy animals, skeletons, lots of shells. And we're going to touch on a couple of those things in a little bit. But yeah, just want to welcome everyone here. We want to give you a little bit of the overview of what you're going to see today. So friends, we will get out there at some point in the program, but just again, you can see it a little bit from here to start. But we're going to be here, of course, at the Wagner. We're going to go back down and catch up with Sue a little bit later in the program as well. But we're going to be in Tinicum, John Hines National Wildlife Refuge at Tinicum, Cobbs Creek. We're going to have some pictures of your sideshow of Fairmount Waterworks. And so it's going to be really pretty awesome. And the one thing that we're also going to do, we're going to go to St. Joe's in a little bit, and with some of our graduate fellows that we work with. And they're going to talk to you about some species diversity in rivers, and also the impacts of erosion and runoff. But it's going to be, we're really excited to do this and be here. So thank you everybody for joining us here today. And without further ado, we're going to go to St. Joe's for Allie and Bethany.
Hi everybody, my name is Bethany and I'm one of the GeoKids fellows at St. Joe's. Right now I'm joining you from the Biodiversity Lab at St. Joe's. So there are lots of really cool animals all around here. We've got a bearded dragon, lots of fish, and lots of turtles. So since we're talking about the Delaware River, we wanted to see what kinds of animals do you guys think would be living in a river. So if you have any ideas, go ahead and drop some thoughts in the comments in the chat box. See if anybody can think of anything that you might think would live in the river. Snakes, that's a good one. Definitely there'd be some snakes. How about some others? Anybody else? And turtles, yep. And that's exactly what I'd like to talk to you about today. So there's all kinds of different animals, including bugs, turtles, fish. They all call the river home. And so we're going to use one animal as an example today. So we're going to talk to you about turtles and how they live in the river. So we don't have any river turtles in the lab that are native to the Delaware River, but I have some really cool yellow spotted Amazon river turtles here today. And they live, let me see if I can show you here. All right, so this is Manny. Manny is a yellow spotted Amazon river turtle. And he is obviously from the Amazon, but just like turtles in the Delaware River, he likes to live along the banks where the water is nice and calm and he can get food and all that kind of stuff. There's another one up top named Sid, but I think he's hiding from us right now. So Manny's going to be our example. So Manny here has a dark shaped dome, and while you can't really see his spots anymore, he does have some yellow markings on his neck. And so he has a side neck, which means that he can take his head out and turn all the way to the side and grab his food. So when they're hatchlings, that's where they actually get their name. They have really bright yellow spots on them that kind of fade as they age and get bigger. Females will completely lose their spots, and males will keep them, but they'll just fade. So they can get to be about 2 to 6 pounds for females and 1 to 2 pounds for males. So those females are going to way outgrow their male counterparts. And unfortunately, they're actually listed as vulnerable. So that's one step down below endangered. So we really need to take good care of the animals that live in the river so that we can make sure that guys like Manny here have a good place to live. So now I'm going to pass it over to the other GeoKids fellow here, Allie, who's going to talk to you about ways that we can keep the water clean so that animals like Manny here have a nice place to live and that we can help their populations rebound.
All right, so thank you so much, Bethany, for the introduction. So I'm Allie, I'm the second year GeoKids fellow here at St. Joe's, working with the Wagner. And today I'm going to be talking to you guys a little bit more about the importance of maintaining good river health. As Bethany already told us, we do have to be concerned about the river health in terms of the ability for different animals to live there. And as we see threats to river health, we see threats to the wildlife that live in these areas. So what we're going to be talking about specifically is erosion and runoff. And my guess is that you all have probably heard those words in some capacity, but maybe don't necessarily have a full understanding of what it is and how it can really impact river health. So that's what we're really going to be addressing. So first, I want to get some solid definitions for us for what erosion and runoff are. So does anyone know or have a definition for erosion? You can drop it in the chat or unmute yourself, raise your hand, whatever. We can get some answers and see if we can build a good definition together. So first for erosion. Okay, so erosion is really what we're going to see when we see weathering happening. That's going to be changing our landforms as a result of water. So as precipitation is coming down, you'll see changes in the landforms as a result of the water. And this is something that you probably have seen quite frequently. If you've ever driven when it's really raining out, you might notice that on the side of the road, there looks like what's forming almost like a little stream on the side of the road. And that's actually erosion. That's weathering because of water happening in the land. And one of the things that happens with erosion is we do see these changes in landforms that can cause major changes over time. But the other really important aspect to consider is the fact that even though we see the water making these physical changes, water isn't the only thing that's going to be moving when we see this happening, when we have precipitation happening, because there are a lot of things that are able to dissolve in water. And that's where we run into this problem of runoff. So when we see runoff, what's actually happening is that that water that we see as precipitation, this rain or the snow or whatever, is hitting the ground, and it's going to move along the ground, and eventually it's going to find its way into a water accumulation area. And an example of an accumulation area could be something like a lake or a stream or a river, and ultimately find its way into the ocean. So everything really is connected here. And so it's very important that we're mindful of the ways that we are trying to minimize runoff, minimize the amount of these harmful pollutants that are making their way into our waterways and ultimately having negative health effects on the animals that live there. So today we're going to be modeling what it looks like to have erosion and runoff happening in 3 different types of riverbanks. And the reason that we're using 3 different types of riverbanks is because there are really 3 different things that out in the, in the wild, you may be seeing in terms of what a riverbank looks like. So the first one that we have here is just soil. So you can see there's a little bit of rocks, a little bit of other stuff, and this would be pretty representative of if you saw a riverbank that doesn't really have anything growing along the side of it. So it's just open space along the side of the river. The next one here is a mixture of soil and gravel. So you can see on the bottom that we have soil, and on the top is just gravel. And what this is representing is things like roads or parking lots, things like that, where we're not having a lot of soil right near our waterways. We have this gravel, which would be considered a little less permeable to water. Won't be able to suck it up as much. And then the last one is going to be what would be most like the most natural kind of riverbank. So again, I still have my soil on the bottom here, but instead of having nothing or instead of having gravel on top of it, I now have other natural materials. So things like leaves, pine needles, grass clippings. And in the wild, what you would see is that you'd have these sorts of things, and you'd also have like living plants actually growing out of the riverbank. And the idea here is that all of this stuff is living, has a pretty high capacity to be able to suck up water. So we're going to see today what it looks like when water runs along a riverbank in each of these 3 different types of riverbank models. And the one thing that's really important is I'm doing this, and I'm saying this as a scientist, is I am controlling this experiment by using the same amount of water for each of my trials. So the observations we're making are specific to what's happening inside of the bottle and not because I'm messing with the amount of water that's going into each of them. So what we're going to be wanting to look for in the observations that I want you to be making as I'm pouring this water is we're going to be looking, so as you can see, I have clear water, nothing in it. And then it's going to be collecting into this collection cup, which is representative of a stream or river, because all of this stuff that's being passed through the soil is ultimately going to make it to the river in our natural environment, okay? So I want us to think about the quantity and the quality of the water that's going to be passing through. So first, if everyone could drop in the chat box, do we think we're going to see a lot of water or a little bit of water passing through this model? So a lot or a little? Okay, a lot, a lot. Okay, a little. So we're kind of split. So it'll be interesting to see what actually happens. And then in terms of what the water quality, do we think the water that's going to pass through, you can see that the water I'm putting in is very clear. Do we think the water that's going to come out, is it going to be clear or have a color? Be cloudy, gray. Okay, so it seems like we are all in consensus that the water is going to have some sort of color, but the amount of water will be maybe interesting for us to really find out. So I'm gonna pour my water in. Oops. Poured too much. So we can see the water is really starting to accumulate in our cup. And it looks like people's predictions about the color is pretty spot on. So we see that some of the soil and the other components in this bottle have been carried out into our river. And we do see that you can see the physical pieces, but we can also see that there is a cloudiness to the water, which suggests to us that there's a lot of stuff that's being dissolved by the water and being carried into our river. Right. Whoops. Tilted it too far. Okay. So I had my water filled all the way up to this mark line on my cup. And we see that I have very close to that amount if we added up this part that I spilled on the counter to what I initially put in. So we see that not very much water was actually absorbed by this model. And if we look at the model itself, we can see that we have some erosion happening, that we can physically see changes in our landscape. And maybe, I'm not sure how clearly it shows on the camera, but there are areas where you actually see no soil at all. So there's definitely movement of the soil in different ways in this model. So the next one we're going to look at is our gravel and soil model. And if everyone could drop in the chat, do we think we're going to see more or less water pass through this model compared to the first one? See less water? Less? The same amount? Do we think the color is going to be the same, or do we think that this would maybe do a better job filtering so we wouldn't see the same kind of color? Cloudier maybe? Be the same? Less cloudy? Okay, so our predictions run all the way across the spectrum here. So I'm excited to see what's going to happen with this one. Here. Okay. Oops. Okay, so from the looks of it, from the start, we're seeing that the water doesn't have as much cloudiness to it. It's not perfectly clear, but it is somewhat clearer than our soil-only model. Oops. Okay. So those of you who predicted that it would be less cloudy, I would say you have it. We don't see very much of the soil, the dirt particles themselves coming into our gravel and soil model. And in terms of the amount of water that we collected, it's about the same between the two. So the last one we're going to look at is this guy here. So this is our mixture of soil and leaf litter. Oh, and thank you to whoever said it's flowing quicker in this gravel model. That's a good point. We'll talk about that at the end when we're comparing them all again. So here we have soil and leaf litter. And so again, let's drop in the chat. Do we think that the water is going to come out very cloudy? Do we think it's going to be cloudier than the other models, less cloudy? Less cloudy? Okay. Looks like the consensus might be for less cloudy. Okay. What about the amount of water that's going to pass through this model? Do we think we're going to have the same amount of water passing through or less? Okay, the most of the three. Okay. Less. All right. So I'm going to get started with this one and we'll keep an eye and see what happens. Okay, so the water is coming out pretty clear. There are still some pieces of soil that are passing through, but not that many. Okay. So now we have all three of ours, our, I guess, rivers that we have here. And looking just at this last one, we see that it is very clear. We don't see that much that has passed through. And I know we talked about erosion a little more in that first model. If we look at the second model, we don't see that any of the gravel has been changed as a result of our precipitation. And we also don't see we don't see any erosion happening in our leaf litter and soil model either. So I'm wondering, what do you guys think? Why would this last one be, I would say of the three, I think it's the clearest. Why would the one that has the leaf litter be the clearest model? What about it would make it better at filtering out some of the, or not allowing it to let some of the soil, some of that runoff into our rivers? So when we are looking at what's actually inside each of these models, that's what's going to help us in knowing how they're going to filter differently. So something like soil is it has a good ability for it to absorb water. We see that gravel isn't good at all at absorbing water, but we did still have some soil that could suck up some of the water. And what I found interesting is that the leaf litter is actually supposed to do the best job at absorbing water, and we actually saw the most water coming out of that model. So sometimes things happen that are a little hard to explain, but the reason why it should be doing a better job at taking up some of the water and not allowing as much to pass through is because it's made up of so many living things or so many previously living things. So the cells that make these things up are using water, and especially this is the case when we have living plants along riverbanks. And so the reason why I did this experiment with us today, and this is actually an activity that I did a few years ago. I was working with the Alliance for Watershed Education of the Delaware River, and created this to try to illustrate to the kids I was working with why it's important for us to have really healthy riverbanks, and why it's so important for us to plant plants along riverbanks instead of putting in things like parking lots and roads right next to rivers, or by just leaving, taking down all of the vegetation along a riverbank. And really, there are some potentially really negative effects from destroying these natural, healthy riverbanks. So the one thing that I really want you guys to take away from this, and unfortunately our model didn't do a great job at explaining it today, is the fact that it is very important to have these very plant-rich riverbanks, and they're very good at preventing erosion, preventing runoff into our rivers and streams. And by preventing those sorts of things, it's helping to make sure that the water is the healthiest as it possibly can be for the animals that are living there. And really just making sure we have great river health overall. So that's it from us here in the Biodiversity Lab. But if you guys have any questions, feel free to drop them in the chat, or we can talk about them during the question and answer session afterwards. But I think now we're gonna flip it back to the Wagner.
Thanks so much, you guys. Can I just ask a quick question? Can you just quickly say what that Biodiversity Lab is? That's Dr. McRoberts' lab, right?
Yeah, so the Biodiversity Lab is on St. Joseph's University's campus. The principal investigator is Scott McRobert. And basically, everything that we're doing in this lab is really focused on conservation, ecology, understanding animal behavior. And we partner with the Turtle Survival Alliance and home certain species of turtles specifically that are pretty endangered. So it's important that we maintain populations of them moving forward. There may be a point in time where these guys aren't naturally existing in the environment anymore. So by keeping assurance colonies, we can make sure that they are continuing on, even if the outside world can't contain them anymore.
I know you guys do amazing work over there, and Dr. McRobert did a series of talks from his lab for us earlier this summer, and I'm sure we'll have him back at some point. We are also really thrilled to work with all of you, St. Joe's people. You're part of our GeoKids partnership, and I know some of the demonstrations you were doing today are like similar to some of the work that we do with kids to teach them about the environment. So we'll be starting that up next week. So I think you guys are going to be joining us in the classroom to teach kids the same things you've just been talking about today. So I think we're switching back to Erin in the museum. Thank you, Allie and Bethany, for being with us on a beautiful day and sharing this incredible work that you're all doing. There's a question in the chat that I'm gonna just throw to you before you tune out to enjoy the day. And the question is, how did an Amazon turtle get to St. Joe?
Okay.
That's a really great question. I'm going to take that, Allie, if that's okay with you. That's a great question, Debbie. Yeah, we're definitely not in the Amazon here. And if they're vulnerable, you'd have questions about how we get animals here. So Dr. McRobert's lab here, the Biodiversity Lab, has a partnership with the Turtle Survival Alliance. So animals that are in a bad situation, maybe they've been captured by poachers or they're trying to ship them somewhere where they're not supposed to go. They can't release them back to the wild because they've been manipulated and they may not know how to go find food and stuff again. So Dr. McRobert's lab takes in those animals, and that's how we got Sid and Manny here as hatchlings, and that's how we get a lot of the animals here. So basically any animals that need a good home, particularly turtles, because we work with the Turtle Survival Alliance. So thanks for that question.
It's a fantastic program, and it's amazing to hear about it. So we'll have you back to talk more about it another time, but thanks so much for joining in. I think we're gonna tune into Aaron upstairs in the museum.
All right, thanks Sue, thanks Allie, thank you Bethany. Yeah, that was really awesome and great to hear from you guys, and also talk about how we work with you and how you guys work with us and help us do our mission here in the city and throughout the city of Philly. We don't have any Amazon river turtles up here, but we do have some other turtles here. And Manny's pretty awesome, and none of these guys are named. Every once in a while, a kid comes in and tries and names one. I don't have any fun names that I remember, but these are some really cool turtles that we have here at the Wagner, and they're not all of them, but a lot of them are local ones. So we have a soft-shelled turtle, which is over here, which is actually from Paulin's Kill, Haynesburg, New Jersey, in North Jersey, and that's actually Paulin's Kill. Actually, is a tributary that connects to the Delaware River. Delaware River, I think here in Philly, we kind of just think about the one that's connecting between us and Jersey, which it does do that. But the Delaware River is over 300 miles, I think 330 miles long. So it goes all the way from New York, all the way down through Jersey, through Pennsylvania, and goes out a little bit more south by Delaware and out here. So you on this map here, again, Paulin's Kill is up here with one of the turtles that we have right there. And then again, it flows down and then kind of flows through past Philly and through Cherry Hill, and then flows out of the Delaware Bay right here. And so I have that circled spot up here because that's where the soft-shell turtle that we have is from. But then you also notice two other spots as well. So we have the second one is Winona, New Jersey, and we have a couple spots, turtles here from Winona, New Jersey. So we have our box tortoise down here, and then we have our speckled tortoise at the top there. So yeah, we have glass cases, so we do apologize for the glare a little bit. Trying to make that work for you as best as possible. And then that last little circle is for where Cape May is and down by the Jersey Shore. And so we do have a diamondback saltwater terrapin right here from Cape May. So we do have lots of turtles and lots of other animals, which I'm going to show you in a little bit. But it's just really, and we wanted to connect the Delaware River to the animals that we have here at the Wagner. And a lot of these things that are up here, we've had, and we're going to walk through this a little bit. We've had them for over 100 years as well.
I have a question, Aaron, about turtles. So we've just learned about 3 different turtles that live in 3 different locations. Is there any time that these turtles might travel between different kinds of locations, or are they animals that more stay towards their home base?
I think a lot of them, to be honest, I'm not 100% sure. Bethany, so I know you love turtles. If you're still on there, you might answer that question.
What is it? I can help you find it later.
I don't know if she heard me. Well, I'll write it in the chat and we'll see.
Yeah, we'll save that for Bethany, because Bethany still works with turtles and has worked with turtles a lot, so she would know that better than I do. But that is a very good question, Miss Rebecca.
Thank you.
But yeah, so we have some turtles here, and we're going to
Micah.
walk through and see some other animals that we have here as well. So as we're walking, you can see the Wagner Museum Gallery, again, which has rocks, fossils, taxidermy animals and skeletons and shells. And on the side here, these are all pretty much our rocks and our fossils and some fossilized shells as well. And the Delaware Water Gap was formed during a part of the mountain building of the Appalachian Mountains. And so you are going to find a lot of rocks, of course, around the Delaware River, especially metamorphic rocks. And over time, as we just talked about erosion specifically, you're going to find a lot of sandstone, a lot of sedimentary rocks that get eroded over time as well. Also, but back to the animal part, if you look right there, we have
on the camera, I think.
Looks like it's about 5 to 6 feet long, and that is actually from the Delaware River. So once in a second, you'll be able to see the label that's on the corner here, and it actually says Delaware River. So this common sturgeon is from the Delaware River, and it's one of the bigger fish that we have here. Not the biggest fish. I'll make sure to point that out when we get to it. But that is one of the fish that we have here, which is
going to transition soon.
From the Delaware River, and it's really cool. And one of the things you'll also notice, maybe not in this one, but in one of the other ones we do have a lot of old labels. So one of the things that we do here, in addition to providing free science education, is preserving this labels that you're seeing, especially with the handwriting. A lot of it's original. Most of it is original, and we try not to change them unless they are in really bad shape. But we want to make sure that this is a really unique experience for people to come here. So we have a lot of field trips, which Sue mentioned earlier, that those all start next week. So I do have a bunch of trips, or there's a couple of trips next week as well already. But just really cool place to come here for field trips and just to visit. And hopefully one day soon we'll be able to actually have people visit here in person. But for now, everything is virtual. And over here, the last part the last couple animals we're going to talk about in this first section, going back to sturgeons, we do have a couple sturgeons on the bottom here. We have a common sturgeon and a short-nosed sturgeon in the back. So those are both pretty cool to look at as well. And one of the things that we have but I kind of don't really think about as being part of the Delaware River, because I haven't personally seen them, but there actually are some pufferfish that you can find in the Delaware River. So that one right there, that's called a smooth puffer, which is another name for that is a rabbitfish. And that one was actually found in Atlantic City. So that one was found more towards the Delaware or the Atlantic Ocean. So smooth puffers are more towards the Delaware, I'm sorry, not Delaware, but the Atlantic Ocean. And they're really pretty interesting to see because they have little spikes on the bottom there. But again, the top, they're named for smooth puffer because of the top. The top is very, very smooth. So you don't really find that one as much in the Delaware River. But the one that you do find is this guy here. So we have northern puffer, which is the one that you usually find around the Delaware River. And then you have the smooth puffer. So just looking at the two, you can see that there's a difference. Again, the smooth puffer is very smooth on the top. The northern puffer has a little bit of kind of spikes on the top, as well as some on the bottom. And then when they blow up, they look like this. So again, smooth puffer on the bottom, northern puffer on the top. And I have a question for everyone out there, but are puffer fish, they're known for something, but are they poisonous? Some people think that they are. Yeah, right, yes, write it in the chat, if you know. But do you think puffer fish, or all puffer fish, are poisonous or not?
We have one answer that says some are.
Some are, yeah, right. So some of them are, not all of them. Which one of these do you think is poisonous? Is it the northern puffer or the smooth puffer? Let's see, which one of these do you think is going to be poisonous? Any guesses?
Northern or in the smooth. We have a guess for each.
All right. So kind of a trick question. They both are poisonous, but different parts of them are poisonous than the other. So smooth puffers, their skin and their organs are really the thing that really gets, which is what is the fatal part. That's stuff that's really poisonous. The northern puffer, the skin is not. So it's used, the northern puffer, it's just the organ. So if you found a northern puffer, you could actually pick it up with your bare hands. Sound not the best thing to do, but you could. But the problem is usually when you pick up a puffer fish with your bare hands, they can secrete the poison and from their skin onto your hands, which again can be very harmful and depending on the fish, fatal as well. But northern puffers you can just pick up with your bare hands. You just got to be careful for the spikes on the bottom. But so most people, I don't think are going to try and do that. But if you're here at the Wagner, one of the things that we do have here is we have specimens from our teaching collection. And so this is something, hopefully I don't contract any poison from this, but this is a porcupine fish. This is not one that you find around here, but porcupine fish have spikes all over compared to puffer fish, which as you can see, just have the spikes usually on the bottom. So, I mean, maybe some on the top, but most of them just have a little bit on the bottom. But you can actually hold a porcupine fish if you're here at the Wagner. We do have a teaching collection, which is downstairs. And when Sue's on video, right behind her, that's where that teaching collection is. So that includes a lot of things that mirror the collection up here, but it also is stuff that you can touch and hold in a non-coronavirus world. But this is just a pretty cool, really awesome specimen that we have and one of our favorites. And the spikes, they don't really hurt too much, but if you hold it very carefully, it's not too bad. And again, it's a real one, and you don't have to worry about getting poisoned or anything like that. So this is a really cool one of our favorite specimens that kids that really like talking about and touching. All right, so we're gonna kick it over to Miss Holly, who's at Cobb's Creek. Miss Holly, are you there? Miss Holly there? Did you hear me, Holly?
I can hear you. Can you hear me?
Yes, we can.
I just came off mute. So can everybody see me here? I'm out here at Cobb's Creek, like Aaron said, exploring my local stream. So Fairmount Parks is a great resource for...
We can't see you.
You can't see you. Is my camera off, Dawn?
Oh, there you are.
Camera's on.
There you are.
Sorry.
No worries.
We were muted and camera off, but we're out here at Cobb's Creek and exploring the water quality of our local stream. And in Fairmount Park, there's all sorts of streams and places you can go to explore with your family. So like Miss Allie was talking about, erosion is a good thing to look at first when you go to explore the water quality of your stream. So you want to look on each side, what kind of plants are growing on each side. And we can see on this side, we have lots of trees, but on this side, there's not as many trees and the sides are rockier. Don, can you show the rocky side? And after a big storm event, you'll get a lot of runoff. And you can really see here, can you see down there where the roots can wash away the soil? And a lot of people don't think of soil as being a pollutant, but it's a very common for the streams, especially after large flood events. But I wanted to just talk about something else that lives in the stream. And if Miss Rebecca can share my, I have some pictures that I wanted folks to look at before we start exploring. Can you pull up the PowerPoint? Awesome. So in the chat box, or if you want to unmute, you can. What do you notice? What's going on in this picture? What are we seeing in this picture? Okay, I'm looking at the chat to see if we have anyone. What's going on in this picture? What do we notice? Michael, what do you notice in the picture?
Lots of bugs are just sitting in line and doing nothing.
Yeah, so we see lots of bugs. There's bugs flying over this bridge, all making it really hard for this car to even, so many that it's hard for the cars to see. And then on the other cars, they all die. So Miss Rebecca, can you advance slide? So all of those bugs that were flying about in the night sky and then dying on the cars in mass are mayflies. And they can be a big nuisance in the May. They're called mayflies and they hatch in May. But they're really an interesting creature that lives here in streams. So they're called macroinvertebrates. Michael, what does that word macroinvertebrate mean to you? Do you know?
Macroinvertebrate.
Do you know what an invertebrate is?
Invertebrate is without a skeleton.
So an invertebrate is without a skeleton. So we know that insects are, you know, an animal without a skeleton, and they will live their part of their life cycle in the stream. So they're a really good indicator of water quality. So in the slide, you can see the adult mayfly. Miss Rebecca, can you switch to the next slide? So that, somebody said what kind of insects? So a lot of insects, and I'm going to give you a resource for all the different kinds of macroinvertebrates, because there are other invertebrates besides just insects that we can look at to understand water quality. But a lot of them are insects. And you can see the next slide here is the mayfly nymph or larva. So that's, you know, after an insect comes out of its egg, it's called a larva or a nymph. And when it's a nymph is when the mayfly is in the water. So the cool thing about the macroinvertebrates is that scientists have figured out that there's a pattern. And when you find certain ones, it means that they're very sensitive to pollution and the water quality is pretty good. If you find other ones, they're very tolerant of pollution, so that you'll find them almost anywhere all the time. And if you could go to your stream and find the macroinvertebrates and identify them, then you can understand the water quality of your stream. So Miss Rebecca, can you turn the slide? So here you can see the way that we group. And can anybody find the mayfly and tell us which group the mayfly is in? The group 1 is the ones that's really sensitive to pollution. Group 2, they're indifferent to it. They'll be somewhere in between. And group 3 are the really tolerant ones of pollution. So when we have those mayflies, what does that mean for our water quality? Can anybody figure out what group 1, 2, or 3 they are a part of? Awesome. Did anybody, Miss Rebecca or Mr. Aaron, somebody at the Wagner, did you guys see where the mayfly fits? Trying to watch the chat and give people time. Awesome. So I have in the chat book, group 3, group 1. So I'm sorry if the slides, maybe it's not as clear and it's hard to read the font, but the mayflies are group 1. So they're very sensitive to pollution. So in the May, when we have a big hatching of mayflies, it's actually a good thing. It tells us that the water quality where they're coming from is pretty good. But the thing about water quality, it changes quickly. One event can immediately kill off animals. So monitoring stream water quality is something that people do all over the country. So if you're interested in doing this as an activity with your family, there's lots of resources for you to do. And then you can report it back to other organizations. So one more slide, because now is a great time. The next slide, thank you. So now is a great time to look for macroinvertebrates in what's called a leaf pack. So leaf packs come in the fall time, all the leaves are falling out of the stream and they get caught up on, and we don't have a lot of fast moving water here, so it's hard to demonstrate. That's why that picture that Miss Rebecca is sharing is a little bit better, but the leaves will fall and then the water will move fast and it'll get collected around big chunks of rocks. And that's where you'll likely to find a lot of macroinvertebrates. So here's a little bit of a leaf pack. And if you go into your stream, you can pick up that leaf pack and see if you can find anything crawling around. Okay. So Miss Rebecca, you can stop sharing now. So thanks for that. And I'm gonna show a little bit of the pictures here as we search through the stream. So you can find a clump of leaves and just see if you can find anything moving. And this is definitely an activity that can take some patience. Don't find any, you put it back down. Another place that you'll find macroinvertebrates is the underside of rocks. And so here's the underside of a rock, and I found another one. So here's a macroinvertebrate, and it's a good example because it's not an insect, it's a snail. And I don't have a cup with me right now, but it's always good to have a little cup because these guys are aquatic organisms. So if you're going to count them or try to figure out identifying them, you're going to want to put them in a little cup like this. And you can see that once you collect them, the next step is to identify them. So there's a lot of resources that you could use to identify macroinvertebrates. So one of the places that I have gotten a lot of information from is the Stroudwater Research Center. I'm trying to find my guidebook too. Here's my guidebook. And on their website, you can download this dichotomous key to help you identify the macroinvertebrates that you find. And then will go through and it'll help you tell you the different parts of the macro. And then it's called a dichotomous key because each step of the way, you're going to be asked a question between two things. Is it this or is it this? So like the first question is, does it have jointed legs or no jointed legs? So for example, that one was an easy one. We just found the snail. This snail has no jointed legs. So after that, there's a next question. Is it a worm-like, no shell, or body enclosed in the hard shell? And then that tells us that it's going to either be a snail or a clam. So this will take you through, and if you have another one, so we've been out here for a while and we can look at one of these other guys that do have jointed legs. I don't know if the camera can pick that up. Can you pick any of that up, Don? Grace.
Can we look at mine?
Yeah, we can look at yours too, Grace. Let's see what we have. Do we have some questions? Is it working? All right.
I think that one's dead.
So there are other ones too that have jointed legs. And I saw somebody in the chat that says Cobbs Creek is an awesome place to explore. Absolutely. We're going to share their website. So, and I think maybe Corinne already did. That's great. And they have free programs as well. So we're very fortunate. We live just a few minutes away from Cobbs Creek and we can bring our family over here to explore and be a part of their programs as well. All right. So we have found a little bit. We've been out here for a while, and I'm going to tell you all the tally marks that we have found. Let me see if I can find it. The good news is we did find some mayflies today. So we found 2 mayflies, but we also found a lot of snails and a lot of aquatic worms. So what that tells us, the snails and the aquatic worms are typically those tolerant. They're very tolerant of pollution. So we're not really sure, but when I was coming up, somebody that works here, Miss Susan, was saying that they recently had a sewage thing happen upstream. So she was really interested, and I'm going to collect the data that I've identified here today and send it over to them, because like I said, the water quality is something that can change in an instant. So it's really has to be monitored and reported back to the places. So that's something that they do here at Cobbs Creek. And I think, like somebody said, this is something that we do with our GeoKids class. So we've come here for many, many years using the Stroud's resources that are available in the Leaf Pack network to count the macroinvertebrates and understand the water quality in different streams around the area. And they are hard to spot. So the best way to do it is to look at turn up a rock and see if something's moving. So I'll try to get to so the sun is shining on the rock and just stare at it. Obviously the snails are easy to find because they've got a pretty hard body, but a lot of the macros will be very good at putting their bodies very close to the rocks, and they can be very difficult to see. And oftentimes they're the same color as the rock, but I find it can be very kind of relaxing to just look in the macroinvertebrates. It's something I do no matter what stream I visit. I have to turn up a few rocks and see. Yeah, the mayflies will be under the rocks too. I think I was reading, they do like to burrow a little bit too. So you can, and we found the ones that we did find, we found them on the rocks. Awesome. So, and is there any more questions? I'm gonna probably clean up here and count my macros and go back to my car to answer some questions at 3:45. Okay, so this is a question too, how do you count them or tally them up? And so this is another resource that the Stroud Water Research has. There's an app that you can get, and they're in 3 categories. And so if you put the number that you found, like I found 2 mayflies, but I found 6 aquatic worms and 7 snails. So I found a lot more of those macros that were tolerant of pollution, but just a few that were sensitive to pollution. So once I put that data into this app, and there's a way to do the manual calculations as well, you'll get something called a biotic index. And that biotic index is going to be like a ratio of each one of those group of things tolerance compared to how many of those things that you found. So I, in total, found like 12 things. 2 of them were sensitive, 10 of them were tolerant. So my biotic index is probably going to be weighted more to those ones that are tolerant. So I'm going to estimate that the water quality here is probably poor. It's definitely not the best water quality. And that's another good thing to remember after you do explore in a stream with your families. It's really important that afterwards that you, before COVID, we had to be thinking about cleaning our hands too, right? So we need to wash our hands and take a shower and make sure that anything that's alive that can make us sick in the stream isn't going in our bodies or home with us. So now actually I'm at Cobbs Creek, and Cobbs Creek is upstream from the Delaware River, and it flows into Darby Creek. And our next folks gonna come to you from the field are Jacob and Mr. Sean down about down at Tennecomm Wildlife Refuge. So rock stacking. I heard, so somebody said, what about rock stacking? I heard we shouldn't do that. Yeah, I probably wouldn't suggest that, because those rocks are a natural part of the ecosystem. So the where the rocks form and will catch the leaves, that becomes a leaf pack, which can be a whole entire macroinvertebrate ecosystem. And the water will run faster over those rocks, and it'll make more water. It'll oxygenate the water. So it's a really fertile and important habitat in the stream ecosystem. So, and if humans go in and stack the rocks, that would alter the stream. So I would definitely discourage that. And, you know, after I count these macros, I'm going to put them back into the stream. Okay, that's a good question. So what do macros generally eat? So like I said, there's a pretty, some of them eat the leaves. Some of them scrape the grime and the algae off the leaves, but some of them, and actually one of my favorite macros is the dragonflies, they eat the other things. So if you find a dragonfly larva or nymph, you can watch, and it has this very amazing jaw. It's crazy to see this tiny little insect larva has this jaw that detaches, and it's a voracious predator in the stream ecosystem. So they have their own little food web, and they're at the base of it. So if the leaves don't fall in, that's going to mess up the whole thing. And if there aren't the right kind of plants on the stream, or if there's too much runoff, then it's going to cause the algae to bloom, or all of these things are very delicate. So that's another reason why they're an important part, because they're intricate part of the food web. That's a great question.
I think I found one.
Awesome. All right, well, it's 3:01, and I think Sean and Jacob are down at Tennekum waiting to tell you all about that. And if anybody has more questions at 3:45, we'll be able to take them then. All right.
Okay, good.
Hi, everybody.
Yeah.
My name is Jacob London. I'm one of the children's educators at the Wagner Free Institute of Science. And we're joined today by Sean.
Hi there, my name is Sean Binninger. I use he, him pronouns. I'm a visitor services specialist here at John Hines National Wildlife Refuge at Tennekum.
All right. And so we know here at John Hines Refuge, we're actually not on the Delaware River. Sean, can you tell us a little bit why we would still be here with the Delaware River Fest?
Yeah, so we are well, here on the refuge, and the Darby Creek actually runs right through this refuge, and the Darby Creek actually opens up and pours out into the Delaware River on the other end of this refuge, so about 5 miles away. So not very far. We're still part of the Delaware River watershed, on a very important piece for flood mitigation and providing important habitat for birds and other wildlife. So very important piece of this watershed, regardless of how close we actually are to the Delaware River.
Oh, very cool. Thank you. And now I usually do most of my work at the Wagner Institute, and we're located in North Philly, over in off of Montgomery and 17th. And the reason that I'm down here and that the Wagner works with John Hines Refuge is because we have a GeoKids program, which is a program we do with local elementary school kids. And every spring, we like to bring some of our classes down here where we do a field trip with them. And we think it's really important to serve our mission of providing public science education to Philly residents, that we're able to bring kids down here to experience this all for themselves. But if you don't get to come here on a field trip, what other sorts of things can we do here, Sean?
Sure. You can come visit on your own on a field trip. It is free to visit. The refuge is open every day of the year. It's from sunrise to sunset that you can visit. Right now, our visitor center and our outdoor bathrooms are closed due to the COVID-19 pandemic. But normally, those would be accessible, and the visitor center would be open 9 a.m. to 4 p.m. Every day except for federal holidays. And during that time when it is open, it's really cool because you can actually check out certain things from the visitor center to borrow and then bring them back. And we can maybe talk about some of those now.
Yeah, what sorts of things can we borrow?
Yeah, so we can borrow some things like fishing poles, other fishing gear, a whole tackle box as well. So that's available to borrow once our visitor center gets back open.
And hey, Sean, do you need a fishing license to be able to fish here?
Yeah, good point. So we've got a fishing license attached right here. So anyone over the age of 16 will need a fishing license to fish here at the refuge. So just make sure that you have that along with your fishing gear. But like I said, once the visitor center is back open, we'll be able to lend out this gear again, as well as some other gear like this pair of binoculars. So we do the same thing. We have a whole checkout, check-in system with our binoculars and our fishing gear. So that's a great opportunity. But beyond that, there's things you can access, while the visitor center is inaccessible. There's still 10 miles of trails for you to enjoy. You can run, you can walk.
Hey,
you
Sean,
can take a bike ride.
You can bring a bike ride?
Yeah.
What are the trails like if I wanted to bring my bike here?
Yeah, so most of the trails are accessible by bike, but some of them are not bikeable. Like we'll see this sign here that has a red line through the bike. That'll let you know that you can't bike on this boardwalk. But most of the trails, like I said, that are pretty wide will allow you to bike. And you can go from one end of the refuge to the other, which is about 5 miles. So you can make a whole 10 miles trip if you really wanted to make a whole bike trip out of it for the day.
Now, I personally don't love to exercise, but I have a furry 4-legged friend who does.
Oh, yeah.
Hey, Nelson, come here.
Let's meet Nelson.
This is my dog, Nelson. Can I bring him to the refuge?
Yes, Nelson is welcome at the refuge. As long as Nelson and our other furry dog friends are on a leash, they are totally welcome here at the refuge. And we actually have while a lot of these things are predicated on the pandemic, but we do have a Bark Rangers program here as well, which invites dogs to become their very own Bark Ranger. And you get a certificate and a bandana. It's very exciting. So your dog can be part of our kind of fleet of dogs that are watching out for one another and their owners. It's a very exciting process to go through. So if you get a chance and are interested, let me know, let Jacob know. We can get you sorted out with that.
That's exciting. Now, other than the dogs that I might see here and the fish that I might catch with my fishing pole, what other animals might I be able to see here?
Yeah, so there's loads of fish and other wildlife to see. People come from across the state and even from other states like Delaware and New Jersey to see the birds that come visit the refuge. There are over 300 species of birds that visit the refuge every single year. So it's a very exciting place. There's a variety of habitats which allows the diversity of birds to visit. We have wetlands, forests, fields. So a lot of different birds will come visit, whether it's the whole year or just for a week or two on their migration path.
Oh, that's really exciting. So it seems like there's a lot of things that you can do if you come here. And as a science teacher myself, one thing that really excites me about coming here is just being able to even come and have fun when you're not doing anything. And I know right now when parents are working with their kids and trying to find good educational things to do, I'm really excited by how much you can get out of just coming to a place like this, just walking around and giving your kid the chance to just ask questions and explore. And I think that that's really one of the best things you can do to learn and develop your scientific thinking with your kids, is to come to a place like this.
Sure. You never know what you're going to see, which is kind of one of the most exciting things to come to a place like John Hines. There's always new wildlife to see. There's always, the changing of the seasons, different plants that are coming up or losing their leaves. So it's a great opportunity to show, what's happening and how things change throughout the year.
Well, since I never know what I'm gonna see when I come here, why don't we find out? Let's take a short walk and a little look around to see what John Hines Refuge is like.
Let's do it. Let's bring Nelson too.
All right, you ready? Here we go.
All right.
Just follow you guys.
All right. Hey there, how are you?
Got a question.
What else is there?
What's your question?
What's there to do in this and
Yeah, so there's plenty, there's about 10 miles of, okay. Oh, sure. Oh,
You can stay with us. Field
Okay.
question. We'll-
all right, yeah. There's about 10 miles of trails to walk. So you can go bike riding, you can go
I'm gonna do a
fishing.
panorama.
There is some kayaking available too.
when did they do that?
So right now our launch is under repair, but you know, we'll probably be getting that up by next season. Back
You
up.
do it right here.
Out on the creek.
Come on, everybody.
Thank you.
All right.
Ooh, come over here and see if we can see any of those turtles, maybe.
Look. Yeah, there's a log over there. Oh, there's actually a row of turtles right over down this way. There's I think 4 of them
Yeah.
right in a row there.
Kind
They're
of
all basking, taking in the sun.
I can't zoom, I guess.
So it's a beautiful, beautiful sunny day, and turtles love to come out. Actually, all reptiles love to come out on a sunny day like today. Being cold-blooded, they really take in that sunlight to get warm. They love to be out and about.
Now, if I wanted to learn more about any of the animals that I might run into or see here, do you all have resources or information that I could use to learn more about these animals on my own?
Definitely, yeah. So right now, during the COVID-19 pandemic, we've been doing bi-weekly Facebook Live programs. Those are Tuesdays and Thursdays at 1 p.m. And we do things like Wildlife of the Week, where you can learn about one species that lives at the refuge. Each week, we do a variety of nature walks, choose your own adventure hikes, different things that will, get a variety of audiences engaged, whether it's our youngest with our Nature Tots program, 3 to 5 years old, or someone older. That's, a variety of the programs that we'll offer. And like I said, it's every Tuesday and Thursday at 1 p.m. And you can check out our Facebook page, which is facebook.com/JohnHinesNWR, to check out all the videos that we've already done. They're all recorded and on our Facebook page, so you can watch those whenever you'd like. And as we move through this pandemic, we'll start to go back to offering in-person programs here at the refuge, and also especially in our Southwest Philadelphia community. We're located in Southwest Philadelphia, very close to the Philadelphia airport. And we have our target community in Southwest Philly. So we try to make sure that we focus our efforts there, but also in the greater Philadelphia and Delaware County area.
Very cool. And I wonder if I can't make it to one of those programs, I really like reading information on placards. You don't happen to have any placards here, do you?
Yes. So about 2 years ago, brand new exhibits were put in that actually highlight some of the wildlife we see here. There's another boardwalk that you can come see, and it has some of those exhibits as well. We have some of these other exhibit signs that talk about the birds you might see out on this pond we have here. So there's plenty of things to see regardless of whether you're on a guided hike. You can come in and really explore on your own. It's a great place to do that.
Now, Sean, so you're telling me this isn't a part of a river or a creek?
It actually isn't. So this is a pond that's separate from the Darby Creek that I talked about a little bit earlier. So this is basically a great management tool because it is separate from the creek, and we can actually control the level of the water in here. So depending on whether we have our ducks coming in as we now are approaching fall and winter, so we'll want to have a deeper water in here to provide more of a that deeper water for the ducks to dive and get plants underneath the water. Or if it's shorebird season, or if it's summertime, then we'll have the water level lower for those birds that like to have basically little to no water on the surface for them to pick out their favorite food.
That is fascinating. Thank you. So are we able to take any questions at this time, or should we pass it along to our next friend?
You shouldn't. Time to move on, Jacob. I think Michael Lewis is with us.
All right. Well, thanks for joining us.
Thank you, Sean.
All right.
Thank you, Sean.
Thanks so much, Jacob. It was great to be here today with you.
Nice to speak with you.
Yeah. Bye now.
Thanks, Jacob and Sean. Michael Lewis is one of the Wagner's professors. He'll be teaching this fall, but he's gonna share a little bit about the waterworks and its role in public health and water quality for the city.
So am I on?
You're live.
Okay, I'm live. Hello, everybody. I don't have a cute dog like that last one who stole the show. Let me share my screen with you and go to my PowerPoint. We have in Philadelphia one of the great moments. You've got it. We have one of the great urban moments in the United States. We have the Philadelphia Art Museum, which presides over our one hill in William Penn City, the Fairmount, fair meaning beautiful, looking down over the Schuylkill River. And at the top of your image, you can see Boathouse Row trickling away into the south, into the northwest. We are lucky to have this because up until the decade before the Civil War, the land to either side of the Schuylkill, where the Art Museum now sits, was slated for development, for being gridded like the rest of William Penn's Quaker grid and sold for real estate development. You're looking at an 1859 plan of Fairmount Park. And this plan is the germ of the park we have today, which is over 4,200 acres, one of the world's great parks. And it exists because of a wonderful medical misunderstanding. And the misunderstanding was America's most devastating pandemic. We think our pandemic today is horrific, and it is. But the yellow fever epidemic that struck Philadelphia in 1793 killed 4,004 Philadelphians. That is 1 in 10. The mortality rate was catastrophic, and it would have been higher had Philadelphians not been able to escape upriver to Germantown, as our president did, George Washington. The mortality rate for untreated yellow fever was something on the order of 20%. And Philadelphia gave America its first great public health initiative, something Philadelphians should be proud of. This is the great alignment of Philadelphia science and the Quaker concern for public welfare. There is Benjamin Rush, really America's first epidemiologist, who wrote his scientific study of yellow fever. And he did everything right. He did everything that a forensic investigator should do. He identified all the people who got sick and died. And here you see, this is an extraordinary document. These are all the deaths in the worst month. This is actually the recurrence of it 5 years later. But it was the same sort of document because you were buried in the church you belonged to. They're all tallied up, and he located the deaths. And if you look at that critical red zone, it lay along the wharfs of the Delaware waterfront, which suggested that the wharfs themselves were the bringer of the contagion. But what exactly was it bringing? What they didn't know, and what no one could know for 100 years, that it was a mosquito, Aedes aegypti, that it was carried by the mosquito, transferring blood from one victim to another. But they came almost up to that discovery. They came almost up to it when they recognized that brackish water was the problem. Now, they thought it was the decaying vegetable matter in it. They didn't know it was the breeding of mosquitoes, but it was realized if you could flush the streets clean with water, you might therefore remove the noxious fumes that they call the telluric miasma. And what you are looking at, this diagram, it's a wonderful illustration of Quaker clarity and rationality. It's America's first public water supply. And if you look at the upper left, water is being taken out of the Schuylkill River, taken through a brick pipe that channels its way all through here and right to where Philadelphia City Hall is today. And from there, it would be pumped into the developed part of the city along the Delaware. And it was brought into this pump house built in 1799 by Philadelphia's great architect who would later build the United States Capitol, Benjamin Latrobe. And if you look at it, the interior is the first application of the steam engine to the water supply. The water that was brought in would be pumped by steam power up into a reservoir at the top. You see the tanks up here would hold 20,000 gallons, then would be released through gravity to the buildup part of the city. But the character of the exterior, Latrobe, a neoclassicist, borrowed the pure geometry of the Pantheon in Rome. That is the most perfect of all geometric forms, the circle. Here, a pantheon of water, a rotunda of health. And instead of light coming in from the top, as in the Pantheon in Rome, smoke comes out, but it's a cleansing smoke. And if you look at it there, it became the center of public life in Philadelphia. This wonderful painting of about 1815 at the Academy of Fine Arts by John Lewis Krimmel. It shows Quakers, young fashionable belles, eating oysters in front of the waterworks with William Rush's wonderful statue of Nymph and Bittern. But it only lasted for 15 years because the technology to build steam engines was very imperfect. The metal plates, the iron plates could not be made consistent enough. You couldn't find the imperfections. They had a bad habit of blowing up. So Philadelphia actually took a step backwards and reverted to the older technology of a mill race, using a water wheel to lift the water up to the reservoir. So what you've got here is a bold, progressive step to use the newest scientific technology possible, motivated by the newest medical understanding possible, and brought together in America's first great public works initiative. But what it meant was that Philadelphia for the next century would be dependent on the health-giving water of the Schuylkill. Don't laugh, at first it was clean water. And in this painting by Birch, you have, I think, one of the glorious images of science and idealism together, because it was beautiful. I can only give you a taste of this today, but I hope some of you, if you're motivated, will take my course that I'm giving for the Wagner Free Institute that starts this week. So thank you for your kind attention.
Thank you.
All right. Thanks, Mike. Thank you, Jacob, Sean, Don, Holly, and family. But thank you guys all for being part of this. And so now we're back here at the Wagner, and what we're going to talk about now are we already kind of talked about some animals that you can find in and around rivers, and you got to see some as well out there, but we're going to talk about some more. But in a little bit different context as well. So this picture I have here, does anyone know what this animal is by any chance? It's kind of semi-aquatic rodent that you can find usually around riverbanks, wetlands.
Someone says otter, maybe?
Not an otter. Good guess though. Not an otter, a little bit bigger than an otter. Any other one?
Beaver?
It's close. Most people think it's a beaver. All right. All right.
Muskrat.
Muskrat. So it's not a muskrat either, but this is called a koi poo, or nutria is another name for it. So the reason I have this picture here is because we actually have a koi poo, and back in the, probably Victorian time, they also had another name for it, which is the raccoonda. So resembles probably a similar niche to a raccoon in some environments. But a koi poo, this is one of our invasive species that you can find around the Delaware River and the Delaware Bay. So I just used the same map from where I had the turtles, but you usually find them usually around the Delaware Bay. So a little bit further south, more in the Delaware, Maryland area than you do around Philadelphia. But there have been some spottings of them as well. So they're native to Central America and native to South America. But they were introduced here in the United States in 1899. First out in California, but they were introduced by fur farmers because they wanted to get their fur. So they were brought here to breed, so that way they can have more fur. They're not as popular for their fur as much now, which is part of the reason why they've become an invasive species, because they're very overpopulated now. But they were brought here for their fur, and then it started out in California, and then they kind of traveled east. So they were in Louisiana in the mid-1900s. Or early to mid-1900s. There was actually they really paid a big fur industry down there. And then in 1941, there was a hurricane that basically pretty much set free all of the koi poo that were there. So that hurricane devastated that area, and all the ones that were not trapped, but that were kept in captivity there, they all got out and then basically spread as all over the United States. So you can find them anywhere, pretty much from as far west as Washington State to Delaware now. So they are one of the reason why they are an invasive species is because of what they do to wetlands, as we saw in Tinicum is a wetland, but what they do to wetlands, marshes, marshlands, and riverbanks. So one of the reasons is they don't hibernate during the wintertime. So the damage they do to those areas, they do all year round. So they're basically just eating vegetation that you find primarily in the wetlands areas and marshlands. And basically, because they're eating so much, it's turning those wetland areas to basically an open river, open sea, open water environment. So, which is flooding and destroying a lot of plant life, destroying a lot of the other animals that depend on that area as well. And again, it's completely changing the environment, so that it should not be. And also, their riverbanks, when they have burrows. And when they burrow into the sides of rivers and riverbanks. And then because they burrow so much, that again leads to runoff and erosion, and that goes into and pollutes the water and changes the composition of the rivers and the streams around here. So they are, Ms. Rebecca said that they look cute. Although they are pretty cute animals. They're also not the safest, and are pretty. They're considered invasive species now. So you're not really supposed to. There's really nothing you really can do about that, but because they don't want, of course, you don't want to harm them, but they are harming the ecosystems that they are inhabiting here in the United States. All right. And another invasive species that we're going to talk about. So we're going to walk down here a little bit. Again, you get to see a little bit more of the Wagner here. This is our draft horse, which is one of our more famous specimens that we have here. It's been here since the late 1800s, and it was bought for about $10 back then. So that's all. It's a little interesting story fact about that. And then over here, we're going to go to our shells. So Holly was talking about macroinvertebrates, and we have lots and lots of shells here, but we're going to focus on one family of them. So this is the New Zealand mud snail, which is native to New Zealand in that area here. But this is a more recent invasive species. So this was first found here in the United States in the late 1980s. So this is more recent, but they have spread very, very rapidly over the past 30 years, since 30, 40 years since they've been introduced here in Philadelphia. And no one really, or not in Philadelphia, United States, but no one really knows exactly how they got here, but they are here. And I'm going to explain probably a good reason why they may have traveled so far over here. So this is a macroinvertebrate, and Miss Holly was talking about the sensitivity of the water and how different macros can determine the sensitivity and how healthy that stream is. So these New Zealand mud snails, they're very resilient. So if you find them, they can basically survive in almost any condition. They can survive without water for 24 to 48 hours. They have a way of sealing their shells shut. So this way they can actually survive without having water if they have to. So we don't have them here. Unfortunately, we don't have any mud snails here, but we do have basically their cousins. So this is family right here, the Litoridae. This whole family is actually the cousins of the New Zealand mud snails. And most of them, you can see, are from New Zealand, Polynesia, the West Indies, Australia area. So a lot of them are from that area. So it's understandable that how they're related. And that picture is blown up.
These ones.
Mm-hmm. Yep, those ones too, yes. So they're about that size. They're usually about a 1/4 inch in size. In New Zealand, they can get a little bit bigger, but then they're obviously blown up on that picture there. But it's just really one of the things that I really enjoy doing here at the Wagner, because I get a lot of questions as a museum educator and interacting with a lot of people, and especially kids, about animals that we have here. So one of the things that I really enjoy doing is finding, connecting those dots. So even if we don't have an animal here that someone's looking for, I like to find out the closest living relative to that you can find of that animal or that plant or organism. So again, we don't have the New Zealand mud snail here, but we do have the Litoridae, which is, so they're basically their cousins. And so it's really cool to be able to do that. But also, just going back to the mud snails, part of the reason why they're resilient too, and this sounds kind of gross, Miss Rebecca, out when I told it earlier, but they can actually survive being eaten. So if an animal, they were typically like a fish, or a little smaller vertebrate would eat one of them, they'll close their shell off. So this way that protects all of their soft organs, soft tissues. And then basically the animal will just swallow the shell, and they'll actually pass through that entire digestive system. And as that fish or that other animal goes to another area and goes to the bathroom, that snail, which you would typically think is probably dead, has actually survived. So they're able to spread so rapidly because they're able to actually survive being eaten. And they really don't have any natural predators in this country, which is part of the reason too. So they're able to survive and spread over a very long period of pretty much have a very wide distribution here in the United States. So it's just really interesting and really cool to learn about, and macroinvertebrates, and again, not just the ones that we like to see, but also the invasive ones as well. All right, and so unless there's questions, we are going to go to Sue back down in the lecture hall. Oh, sorry, yeah, lecture hall, yeah.
Yep, I'm still in the lecture hall. Thanks, Aaron. Thanks for all the background about the museum. I'll just say really quickly that the museum was set up, that display that you're seeing was all set up more than 100 years ago in the 1890s by really key American figure in biology, all forms of biology, Dr. Joseph Leidy. And he's responsible for the arrangement of the museum, which hasn't changed too much since it opened in 1891. And we always like to share that, but we have an amazing rich set of collections that we teach from, and thanks, Aaron, for sharing that with everyone. It's been great to share so much of our education staff with you, and we're going to shift gears a little bit. And first, I want to say that we've been starting up all our programs, and this fall, we're doing everything virtually online, learning how to do it, and are really happy because we're reaching a really wide audience of people who are able to tune in with us. One of the programs that we do, aside from adult education evening programs, which will start this week and you saw that in your chat and got a glimpse from Professor Michael Lewis, is we also do bi-weekly free lectures as part of our weeknights at the Wagner lecture series. And we started those a couple of weeks ago, and we've got another one coming up on October 14th, which will be kind of relevant to what we're talking about today with rivers and streams. Our guest will be Dr. David Robinson. He is the national malacologist for the US Department of Agriculture, and he works a lot with threats that are posed by invasive species that come here from other places and get shipped around, especially by different forms of shipping and transportation. So one of the most dangerous and the one that is threatening a lot of agriculture right now is the giant African snail. And he's going to talk about how they're trying to mitigate that in Miami. That's on October 14th. And you can sign up on our website or our Eventbrite page. And we have lots more coming up later. We're kind of very focused on the environment and on health and public health issues this fall. We'll also have a speaker in December, one of the major people looking at climate change, Dr. Robert Kopp, who's at Rutgers, and then a historian of science who will, Dr. Megan Chernick, who's over at Penn, and she works on how the New Jersey Shore started all these resorts for people to escape health problems in the 19th and early 20th century. So we hope you'll join us for those. But now we're going to shift gears. Most of these kinds of programs and talks that we offer are usually here at the Wagner and in our historic lecture hall, which Corinne is going to show you, and our librarian, Lynn Dorwalt, is here because those talks historically have been illustrated by large-scale glass lantern slides. And we have a working lantern slide projector that we want to share with you. So we're now going to switch and show you our lecture hall really quickly. And Lynn is going to talk us through a demonstration of how lantern slides work and share some of the images from those collections. Lynn with us now?
Hello?
Yeah, we can hear you.
Hi, Lynn.
Hi.
Good to share our projector with everyone. I'm just going to be turning it on.
Yeah, so this is the projector that was purchased in 1914, and it has been in our lecture hall ever since. It's a Bausch & Lomb stereo opticon, and it can project slides. And oh, can we look at the projector? It can project slides, and then it has an overhead projector that projects out of the top. Sorry, I'm not quite sure what's happening. Where's Susan? Oh. You're on mute, so I can't hear. I don't know what's going on.
Can you hear me, Lynn?
Yeah, sorry, you were on mute.
Ah, okay.
Yeah, I was trying to prevent a little echo.
Okay.
The type of lantern slides that are used at the Wagner and were prevalent in the late 19th century and early 20th century are photographic glass slides, in which if you could take it out of the plastic, they can see the slide. A photographic image is developed on one piece of glass and then sandwiched in between another and taped around the edges for safety. And then they can be put in a projector and projected like any other slide. And that huge plaster screen, oh, you can't really see the image. Oh, there you go. So I don't know if you can see well enough, but that's the Ben Franklin Bridge. And that plaster screen, which goes almost the entire height of our lecture hall, that was put in 1915. And so the Wagner has a collection of nearly 5,000 glass slides that were used to illustrate our evening adult lectures. Almost about 750 of those are engineering slides used to illustrate our engineering courses that were taught by Samuel Tobias Wagner, who was William Wagner's great nephew. And he was a civil engineer for the city on many different projects, and then became the chief engineer of the Philadelphia and Reading Railroad. So I'm going to show you some slides of bridges from his courses that are all in Philadelphia. So I'm going to share my screen and show you some bridges. All right, there we go. All right, so this is the Gresham Aqueduct. It was built in 1892 by the Department of Public Works. It is a stone arch bridge that carried the city's first intercepting sewer over Gresham Creek. So an intercepting sewer, it picked up the flow of sewers that had formerly run into the Wissahickon and the Schuylkill, polluting them, and this diverted them away from the city's drinking water. And here it is under construction. This arch bridge still exists. If you've ever been to Devil's Pool in the Wissahickon, that is the arch that you see. You can also see in the back of it, behind it, there's a little wooden walkway that pedestrians used to be able to walk over. That does not exist anymore. This is the Falls Bridge over the Schuylkill River, and it was built between 1894 and 95. It's a steel Pratt truss bridge with stone masonry, abutments and piers. And this is one of my favorite slides in the collection. You can see two little kids looking out over the bridge. It connects Kelly Drive and Martin Luther King Jr. Drive. And here, this is it under construction. It was designed as a double-decker bridge, but the second level was never built. And this is a rendering of the Walnut Lane Bridge over the Wissahickon in Philadelphia. It was built between 1906 and 1908, and it's a concrete arch bridge, and it connects Germantown and Roxborough. It was a Department of Public Works project and part of the City Beautiful movement in Philadelphia in the early 20th century. And here are a few shots of it under construction. You can see the wood frame that was built in place to pour the concrete over. At the time of construction, it was the longest and highest concrete bridge in the world. And this is the Columbia Railroad Bridge. It's a concrete arch bridge across the Schuylkill designed by Samuel Tobias Wagner when he was the chief engineer of the Philadelphia and Reading Railroad. This is the third railroad bridge that was built at this location across the Schuylkill, and it's the one that's still there today. It opened in 1920 with 2 tracks, and then here you see it in 1921, it was extended to 4 tracks. And it's most recognizable as the bridge that the regattas on the Schuylkill go under. And then here we are at the Benjamin Franklin Bridge, which during the dates of our lantern slide collection was the only bridge across the Delaware between Philadelphia and New Jersey. And it was originally named the Delaware River Bridge until they started building the Walt Whitman Bridge in 1955. And they changed the name to the Ben Franklin Bridge. It is a steel suspension bridge that was built between 1922 and 29. You can see pictures of it being built here. At the time of its opening, it was the longest single span suspension bridge in the world. And you can see here a close-up of the steel suspension cables that were bound. And here's a close-up of the end of one. And you can see the man on the right, those cables are probably at least 2.5 feet wide. And this is my favorite view. It's a pretty terrifying view onto the Delaware River. And then this is the Chestnut Street Bridge, which is the oldest bridge, but is not the current Chestnut Street Bridge. It goes over the Schuylkill River in Center City. It was a cast iron bridge with granite abutments and piers that was built between 1861 and 66. Most of the original bridge is gone, all that beautiful cast iron work. But I believe that a couple parts of the granite abutments and the central pier are incorporated into the current bridge. And then finally, I'm just going to show you a couple beautiful shots of arches over the Schuylkill River. This is a railroad bridge. You can see the car above it. And a little idyllic shot of Fairmount Park and the Schuylkill. And that's it.
Thanks, Lynn. That was fantastic. And just reminding people that we do an annual lantern slide salon. This year it's virtual. Lynn will be showing more from our collection, and we'll have 3 other institutions. Lynn, can you just tell us a little bit about it?
Sure. The other presenters are the Philadelphia Horticultural Society, the Swarthmore College's Peace Collection, and the Library Company of Philadelphia. And there'll be shots of gardens and other places in Philadelphia, Europe in the 1930s, some more engineering slides, lots of fun things. And these will all be from digitized collections that these libraries have, since we can't be in person.
But we hope next year that we're back, and the lantern slide projector that we tried to show you remotely today can actually be viewed in person and in use. You know, won't be announced till next year, but it's always in October. So thank you, Lynn, for sharing from our amazing collections.
You're welcome.
So I think we're going back to Holly and Aaron now.
Yes. Yeah, anybody have any questions for any one of us while we're still here? Holly, are you back? Are you still at the stream, or are you back home?
I'm back home now. Can you all hear me?
Yeah, we can hear you.
Awesome. So I did come back. It's really great. I live so close. Just took a few minutes. And I don't know if you can all see this, but I have the app from the Stroud Water Research Center. You can download it. Costs a few bucks, but anytime you do, if you really want to collect the data and monitor the quality each time you go, because like I said, it can change very often. There's this app that you can keep your observations in, and then you can, it'll give you a GPS location, the weather. There's lots of different kinds of tests that are possible to do that I didn't talk about today, but you could measure the oxygen, the pH, the temperature of the water, and take all of those bits of data and put it in this app. So I did come back, and one of the best part is you can put in how many macroinvertebrates you found. And like I said, it'll do the math for you based on whether or not those macros that you found were sensitive to pollution, tolerant of pollution, or somewhere in between, which I think is called facultative. They'll be in good quality and not so good. So you can see here the number we got is 8. So that is not very good. It's very poor water quality, and that is kind of on par with what Miss Susan at Cobbs Creek told us, that there was a sewage leak or an water quality event in the last few weeks. But she can take this data, or we could go back and continue to collect the macroinvertebrates and get a number to see if that changes over time. And it does the math for you already. So it's kind of nice. The biotic index calculation is a number from 0 to 10, and a high score is a bad score. So closer to 0, the better the water quality, closer to 10, the worse the water quality.
Holly, can you share the name of that app in chat for folks?
Yeah, I'll see if I can find the app, but it's from the Stroud Water Research Center.
We have a question for Aaron. Aaron, this is a question from Facebook that says, what is the most unique or weird item in the museum? So this is going to be kind of an opinion question.
Yes, definitely an opinion. Most unique.
Or weird. So
weird.
I prefer unique because this is all very normal stuff.
Okay, I will say this. My favorite specimen here is actually something. Ooh, can I show? I can show you. I can show you. Sorry. Now you asked that question. You opened. So I'm going to show you. This one is probably my favorite one. And as a geologist, this may disappoint some people, but it's not a rock. It's actually this specimen here, which is called Tooth Story. And this is my favorite specimen here in the museum because it just, speaking of unique and weird, that's what it looks like. But it's also, I think it's when I first saw this, it took me a second to realize what it was. I just was like, how does one person have so many teeth? And so that doesn't make sense to me. But then I realized that is the skull or part of the skull of a child. So you have all the baby teeth that would be visible in the mouth. But under that, that's where all the adult teeth they're sitting there, waiting to come up. And over time, as the root of the baby teeth wears away, when a kid has a tooth and the tooth starts getting loose, the reason is because the root is being worn away and absorbed or resorbed, I forget the exact term, but by the adult tooth. So as that's coming up, it's wearing away at the root's loosening up the tooth, and then once the tooth actually comes out, that means the root's no longer there, and then you can actually get the two. My favorite specimens here, and the other one is actually a specimen that you can't see. Typically, if you were here a visitor, it's actually on one of the top shelf. We have a mastodon skull up there. It's all up there. You probably can't get a good view of it, but it's actually covered. But it's up on the second floor balcony, which has a lot of storage and a lot of other specimens. But we used to have I think it was in the 70s or 80s, there was a mastodon exhibit here, and we got to keep one somehow. And while all the other ones went back to the other museums, we ended up keeping one of them. But that's sitting up atop there, and that's really cool because it's a mastodon skull, and we have the tusk too. So you can see an elephant by comparison. You have two elephants on the top there, the African and the Asian elephant, but the mastodon skull is pretty much the entire size of both of those skulls combined. So it's really cool, again, just to get that perspective on how things have changed over time. And I think that's that's also one of the reasons why I love working here at the Wagner, is because again, you see the passage of time here and see how things have changed with how things are named. And also with the specimens, a lot of times the colors most of the time the colors get faded over time, over the 160 years that the Wagner's been around. And so you get to see see how things have changed over time. And it's really awesome to be here and working in this space that is so not changing. So you get to kind of see how things change over time as well, which is awesome. And then speaking of apps, the one app that I don't remember if it was mentioned yet, but we have an app called, or not we, but there's an app that you can get called iNaturalist, which is kind of lets you, if you see an animal outside, especially around the Delaware River or anywhere in any ecosystem, you can take a picture of it and it'll actually identify it for you. And I'm sure there's other apps like that, and I'm sure there's ways people probably are using that for research and stuff like that. But that's just it's a fun app that I like to use. It also sometimes it works on the museum specimens as well, if they're not too faded, because again the colors will fade over time. But if the colors aren't too faded, it'll actually identify the specimen that we have here, which is really cool and pretty fun to play around with when we have the time. But yeah, that was a good question. Sorry, that was a long answer, but that's a good question. Any other questions for anyone else? Any of our other speakers and guests today?
Amy says, thanks for your answer.
Yeah, you're very welcome. Thanks for the question. What else? But yeah, we have Holly, I guess this question for you that I had. How many snails did you end up finding at Cobbs Creek?
15. So the snails and the aquatic worms, and those were both they're very tolerant of pollution. So that's really what tipped the scales on the biotic index calculation. 15 snails and 6 aquatic worms. And then the mayflies, there were 2 of those and 2 caddisflies. And those are the ones they can be sensitive to water, pollution, and usually indicate good water quality. So this is a good example. Just because you find a mayfly, it really doesn't necessarily mean it's good water quality. It's really a ratio of how many total kinds of macroinvertebrates you can find and what their tolerance to pollution is.
Awesome. Yeah, thanks for that info. Yeah, it's talking about snails. It's kind of again talking about the mud snails that I showed earlier. So yeah, those are very tolerant of pollution. So. All right. Anything else before we go for any of our speakers? Anything else?
There's another question for Holly. Holly, you see that question? You're muted.
That's a good question. So the question was, what happens in the winter when the water freezes? So I do know they overwinter and they don't die. So I think a lot of them, they will come out in May and, hatch, the adults hatch, the mayflies specifically. And I think a lot of the other larvas, insects that are macros, will mate and lay their eggs, and those eggs then will overwinter. So I'm sure that, some may die, but I think that one of the main ways that insects and invertebrates deal with a loss of life is they lay thousands of eggs, right? So if some of them die, some of it make it, the population is able to continue. So they do overwinter, and there's probably a certain level of die-off, but I wonder if being in the leaves might help cushion things up too. I don't know if Allie or Bethany have studied macros or invertebrates to know any more details about that question, or anybody else, but that's a really great question. But most of them overwinter, and I think some larvae can live a few years before they actually emerge. I don't know all the different kinds of species, but.
All right. So Sue, did you want to add anything else before we go, if there's no other questions?
I don't. I just want to thank everyone for doing this program today. And I popped back up into the overview of the museum just to put you in some context, Erin, and to remind a little plug for everyone who's interested to come visit the Wagner. We haven't announced our reopening of the museum, but it'll be coming soon. And in the meantime, you can join us for lots of programs. Erin's doing virtual tours of the museum. We've got weeknights at the Wagner Talks. We've got evening lectures with the professors you saw. And of course, Lynn provides access to our collections for research, but also we'll be hosting the annual Lantern Slide Salon on October 22nd. So we have a lot coming up. Check our website, check our Eventbrite, Facebook, Instagram, and Twitter. And we hope to see you at the Wagner soon. Thanks.
Right, bye, everybody.
Bye,
Bye, everybody.
Thanks for everything.
Enjoy the river.
Wow, that was amazing.
Let's do it. Virtual programs all the time.
Guys, that was fabulous. Thank you so much. I applaud you. Thank you so much.
I think we're still live and we're still recording.
I'm gonna stop the recording now, okay?
That'd be great. Can we stop the live?
You don't want to be live all the time for the rest of the.
Well, I
the
do
day.
want to be alive, but just not
No, I'm
streaming
not
on
alive.
Facebook.